stimulates the sympathetic branch of the nervous system. Arterioles constrict, veins or dilate depending upon where we are, but largely affecting blood pressure. Blood pressure goes up as a sympathetic response. There. You relax them, blood pressure comes back down. Bronchioles dilate with sympathetic to get more air, more oxygen, you need more oxygen. Right. Digestive tract, sympathetic inhibits the digestive tract so that we can send all the blood to the muscles. Parasympathetic increases the digestive tract so that we can get blood to the digestive system to do digestion. Secrete a lot of enzymes with the parasympathetic response for digestion. Don't secrete them with the sympathetic. Parasympathetic stimulates insulin secretion. Should make sense. Digestion. Sympathetic inhibits it. No digestion. So these things these sympathetic and parasympathetic responses should kind of make sense. Now, I should mention that when you usually get, especially a sympathetic response, it is a global response, meaning it's the whole body. Rarely do we send it to a single place only. It goes to the whole body. Parasympathetic, you have more control to send it to a single place, but it often is a systemic response as well. The reason with the sympathetic that it becomes a systemic response is that it also stimulates the adrenal glands to secrete epinephrine. Epinephrine gets transported around the body in the blood as a hormone. It does the same thing norepinephrine does, so it enhances all of it. And we'll see that when we talk about regulating physiology in context with some of these processes. We'll see that that creates a problem. This is what we mentioned before. This is the differences between, let's go back because there's some anatomical differences here. This is like the table we had before, except this table compares sympathetic and parasympathetic. I think in anatomy you made a table that was similar to this or whatever, but just to refresh your memory, the sympathetic branches are what we call thoracolumbar, meaning that that preganglionic axon comes off either in the thoracic region of the spinal cord or the lumbar region of the spinal cord. Parasympathetic, cranial nerves, and also the sacral plexus. So we talk about this being craniosacral. Where are the ganglia? Interestingly enough, this ganglion right here, if it's the sympathetic branch, it's closer to the CNS. So in the sympathetic nervous system, we have a short preganglionic axon and a long postganglionic. In parasympathetic, it's the opposite. Long preganglionic synapse, short postganglionic. So the ganglion's near the effector. Again, no real significance of that, except that these are almost direct opposites of each other, right? Which is they're direct opposites physiologically as well. They can have varicosities and release from terminals. The neurotransmitter that's released by the postganglionic axon at the target, norepinephrine in sympathetic, acetylcholine in parasympathetic. So again, we have a difference in the neurotransmitter that's being released. The receptors are called adrenergic here because they bind to adrenaline, which is norepinephrine. These are muscarinic cholinergic receptors. Just they create a second messenger system there, so it's a GPCR coupled receptor. In the ganglion, it's always, as we mentioned before, always excitatory, always acetylcholine on an excitatory receptor. So this just shows that graphically, kind of what's happening. Parasympathetic or sympathetic, actually this would be a short preganglionic axon, the ganglion would be up here, long postganglionic, ACH, nicotinic, norepinephrine, adrenergic. Okay. This would be down here, long preganglionics, acetylcholine, nicotinic, short postganglionic, acetylcholine, muscarinic. Right? So it's just, opposites almost. Right? Opposites. So in